Today's lecture will be over Chapter 3, Section 1, Objectives. Number 1, explain how annual changes in the relationship between the Earth and the Sun causes seasons. Number 2, identify the factors that influence weather. And number 3, describe the main types of extreme weather. So the first thing that we're going to do is that we're going to look at the lecture notes here. What we talk about is the Earth is tilted at a 23.5 degree angle relative to the Sun. The areas of the Earth get more or less direct sun in different times of the year. And so the seasons are related to the Earth's tilt and the revolution. Now, what we see is that we're going to see on this lecture, the question is that what causes the seasons? Why do we have summer, winter, autumn, things like that? And so what we look at is that we look at solstices and equinox. Solstices mark the beginning of summer and winter. The sun's rays directly overhead at noon at the furthest points north and south, and the equinox marks the beginning of spring and autumn, and the day and night are in equal length. I know that sounds very confusing, but we're going to show a quick video to show you kind of some visuals here, and then we'll kind of come back and explain what we're talking about.
Spring equinox on the 21st or 22nd of March. The overhead sun is over the equator. The equator receives the largest amount of solar radiation. At this time, the northern hemisphere is in the spring equinox, while the southern hemisphere is in the autumn equinox. The angle of the sun decreases towards the poles. On this day, the two hemispheres receive a similar amount of solar radiation, and the length of day and night is the same at all places on the Earth. After this day, it is spring in the northern hemisphere, where the day is longer than the night. In the southern hemisphere, it becomes autumn, when the day is shorter than the night. Summer solstice. On the 21st or 22nd of June, the overhead sun is over the Tropic of Cancer. It receives the largest amount of solar radiation. At this time, the northern hemisphere is in the summer solstice, while the southern hemisphere is in the winter solstice. The angle of the sun decreases towards the poles. On this day, the length of daytime of the northern hemisphere is the longest in the year, while that of the southern hemisphere is the shortest in the year. Besides, there are 24 hours of daylight at the Arctic Circle and 24 hours of darkness at the Antarctic Circle. Autumn equinox. On the 22nd or 23rd of September, the overhead sun is over the equator again. The equator receives the largest amount of solar radiation. On this day, the northern hemisphere is in the autumn equinox, while the southern hemisphere is in the spring equinox.
Okay, so what we're really looking at, the question is about what, or I should say, really what causes the seasons to happen. So what we have here is that we've got the sun that's going to go ahead and it is going to shine its light and the rays onto the Earth right here. Now those rays, again, when it comes from the sun and it hits right in the middle near the equator, it's going to warm things up. So when the Earth is straight up and down, we're going to go ahead and we're going to see the northern hemisphere and the southern hemisphere gain that equal light. Now what we have is that we have the Earth that can go ahead, and I'll just go ahead and erase this here. But what we can see then is that when you have one pointed towards the north. So this right here would be the northern hemisphere. And what happens is that when we get really pointed towards the sun, the earth gets those direct rays from the sun, and it really starts to warm up. And then of course conversely in the winter, or in the winter southern hemisphere and the winter solstice, we start seeing it basically getting colder. So the big thing to understand about this, and I'll go ahead and delete everything here, but the big thing to understand about this is that with the sun right here and the earth basically revolving around it, what we see is that, and I know this is a bad picture, but the rotation of the earth actually, it doesn't get closer. A lot of people think that the earth is going to go ahead and it's going to get closer to the sun and then get further away, and then it's going to get closer to the sun and get further away, and that's a rotation right there. That's not right. We go ahead and we see a perfect rotation, and if you want to get technical, it's not perfect. It does kind of bow a little bit. If you think about somebody sitting on top of a ball, that's more how the rotation looks like. But for kind of our general purposes, you're going to see the sun is going to stay here, and it's going to go ahead and the earth is going to rotate around it pretty much perfect. And of course we know that the earth is going to be spinning, and when it spins in 24 hours. And again, if you want to get technical, it's about 23 hours and about 58 minutes, 58 and a half, something like that. Excuse me, but again, it takes, again, about 24 hours. Now, how long does it take to get all the way around the earth? 365 and 1/4 days. That's, of course, why we have our leap year every 4 years. And again, this is going to go ahead and this is going to be the same over and over and over. But what we're looking at is with the earth in regards to the sun, is we're looking at how it's tilted. If it's straight up and down, it's going to be an equinox or equal. If we go ahead and we see it tilted, which we do see it get tilted, we get our solstices. So what are solstices and equinox? Again, a solstice is when it is tilted as far to the sun or as far away. It's the exact same date. Again, what we see is in December 21st or 22nd. And then you're going to go ahead and you are going to see in June 21st or 22nd is when you start to see those solstices occur right there. So what we have then is that we have the reasons for the seasons is because the earth is tilting. Again, not because of the earth getting closer to the sun. Now, weather and climate. Weather, atmospheric conditions at a particular location and time. Climate, weather conditions at one location over a long period of time. This is important for us as geographers because we have to look at weather and climate. Climate, again, basically, and the way to determine between the two is that climate is going to be what we see over a long period of time. It's going to be the average, whereas weather is what is out there today. So if you look at the Weather Channel, you're looking at what is going on today. If you're looking up climate, you're going to go ahead and see something that's probably going to be a little bit longer, 2, 3, 4 months, 6 months, even a year. So what I have today is I brought up the Weather Channel, and there's a lot of things that are going on. And what you're seeing is that these weather patterns are basically moving from west to east. If I go ahead and I kind of start zooming in a little bit on Nebraska, that might be a little bit too far, but what we're going to see is that these are going to go ahead and they're going to come from the west to the east. Now, why does it go west to the east? There's a couple reasons for that. First off, what we see is that you can see these weather patterns coming straight down, and this is very, very common. What we have is we have Arctic winds, and what an Arctic wind would be is that these weather patterns come down from the north. They're going to hit the Rocky Mountains right here, and they're going to go ahead and you can see the line that they follow, that they're going to come right down, right through Omaha into this area and then continue east. Now, what we also see then is that we see some of the weather patterns from the south, and what happens is that right into this area we're going to have warm weather called the Gulf winds, and these Gulf winds are pushing up north, and you can see that some of this stuff is getting pushed up north right there. Now, right now it's December, and so looking at these weather patterns, you're seeing the weather patterns being very cold because those Arctic winds are coming down, also because of the tilt of the earth. But what we also see see during the springtime is that these Arctic winds are still coming down, but the Gulf winds are coming up from the north. And we all know what happens when warm winds and cold winds get together and hit, and they kind of rotate. That's where tornadoes hit. If you've ever heard of Tornado Alley, Nebraska, Kansas, Oklahoma, the parts of Texas. And why this is that you get the warm winds coming from the north, the Arctic winds coming from the south, from the north, the warm winds coming from the south to the north. They basically kind of get wrapped around, and then they get pushed, and that's what causes the kind of bad weather patterns. So again, why do we see certain weather patterns? A lot of the Arctic winds, a lot of the Gulf winds, and then of course we can see the hazardous ones for different reasons. Now, we can also see other things that are going to influence weather, not so much cause it, but influence. First of all, the cause is going to be the sun, about how much solar energy you receive. In the areas down near the equator, you're going to get a lot more warm weather because of the sun's direct rays hitting at that spot. You're always going to have good, it's again kind of that middle latitude right there. And what you see is that when you start getting in the equator, it's always getting sun's rays. It's always getting the good sun's rays, so it continues to be warmer and warmer and warmer. You also see water vapor. This determines whether there will be precipitation. If there's water vapor in the air, it gets too heavy, it condenses, and that's where we start seeing precipitation. Precipitation is when water droplets fall as rain, snow, sleet, or hail, depending, of course, on how cold it is in our atmospheric conditions. We also have cloud cover. Cloud cover may hold water vapor. It can also cool down and basically block the weather. You guys know this when you go outside during the summertime. It's 100 degrees, and then all of a sudden a cloud goes over top. It's not as bad because you're getting that cloud cover. So our weather patterns are very determined by what's going on in the world. Other things, landforms and bodies of water, what we see is that water heats slowly and loses heat slowly. Land heats up rapidly and loses heat rapidly. So if you live on land, it's going to be able to get warmer quicker, but it also loses that weather fairly quickly. Elevation is also a factor. Something very easy: the higher up you go, the air becomes thinner, can't hold moisture, and so what we see is that it snows more and it cools things down. Also, we see air movement. It's going to distribute moisture and solar energy. So if you've got winds that are blowing, you're going to go ahead and you're going to see a more calming, cooling effect. When you stop seeing that air movement, that's when it can go ahead and it can start getting warmer. Precipitation comes about when warm air rises, cools, loosens the ability to hold the water vapor. Water vapor condenses into the droplets like we just said, and then water droplets form from clouds. Heavy clouds release droplets of rain and snow, and so what we see is that the more water vapor you have, the more likely that you're going to get a lot more precipitation. Now there's three types of precipitation: convectional, orographic, or frontal. We don't go into those too much, but those are basically the different types. Now we also have something that's called the rain shadow effect. Now with the rain shadow effect, and I'm going to go ahead and just draw this in, what you're going to see is you're going to see mountain ranges. And what we have is that we've got winds that are going to go ahead and they're going to go into the mountains right here. Now what we see is that these clouds are going to go ahead and they're going to get pushed into the mountains, and so they just kind of stay on this side right here. Now eventually what happens is that these clouds are going to kind of get stuck and kind of get put into get heavy with the water vapor, and you're going to go ahead and you're going to see them go ahead and they're going to start to snow and sleet and hail and just have water on this west side right here. Then what happens is that the clouds get lighter, they go over the mountains, and then eventually they will go ahead and they will come down, and they will go ahead and they will become heavier, and then they'll go ahead and they'll rain, snow, sleet. But this side right here is where we look at. This side right here, as you can see, is going to go ahead and it is going to cause basically almost like a desert area. And so what we see is that this is called the leeward side, and this area is going to basically have very low precipitation. An example of this is going to go ahead and it's going to be in the Rocky Mountains here. On the east side of this right here, if you've ever driven out to Denver or anything like that, the area right in here is going to be that leeward side that's not going to get much water. If you go out to Denver, again on the east side, you're not going to see a lot. You're going to see things like shrubs. There's not a lot of good prairie, grassland, things like that. And in western Nebraska, you're going to see a little bit more difficult to grow things. All of that stuff is because of the rain shadow effect. Now we also have hurricanes. Hurricanes are going to be huge storms, also called typhoons, or I should say typhoons can occur because of this. These form over water, tropical oceans, hit land with heavy rain, high winds, storm surges. Also tornadoes, powerful funnel-shaped column, spiraling in air. We kind of talked about this, born from the strong thunderstorms, capable of immense damage. It's interesting that we actually see that tornadoes are the most destructive, but hurricanes are the most powerful. Why is this? Because hurricanes usually occur over water where tornadoes are over land. Other extremes, we see blizzards, heavy snowstorms with strong winds and reduced visibility. A drought also can be a weather extreme, and we see long periods of time where there's no or minimal rainfall. We also have floods, and this is when water spreads out over dry land, and usually this can be a good thing, and it can also be a bad thing. Sometimes flooding is good because it can make the soil more fertile, but of course it can destroy things, which is not a good thing. This concludes our lecture over Chapter 3, Section 1. Please complete the assessments at this time.